Let's talk about this fascinating project called Claude-of-Duty. It's a first-person shooter built entirely in the browser using 3JS. What's the big deal here?
Claude-of-Duty is remarkable because it's a high-quality FPS that runs entirely in the browser. It uses 3JS 180 and WebGL, and it's roughly 55,000 lines of code spread across 11 subsystems. The best part is that it's built by AI agents under orchestration, not a single developer.
No art assets, no models, no HDRIs, no image or audio files. How is that possible?
Exactly. Everything is generated procedurally at load time from code. There are no external assets. The only runtime dependency is the 3JS library. This makes the project incredibly self-contained and easy to deploy.
So, how does the game handle things like textures, animations, and sounds without any external files?
The game generates textures, meshes, animations, and even sounds procedurally. For example, it has a GPU texture forge that creates 19 different procedural surfaces, like concrete, brick, and metal. It also uses noise functions to ensure everything tiles seamlessly. Sounds are synthesized using the Web Audio API, with no audio files involved.
That's some serious technical wizardry. How does the game manage to run so smoothly without any assets?
It's all about optimization and smart design. The game uses advanced rendering techniques like HDR pipeline, cascaded shadow maps, and GPU-based bloom. It also includes a physics engine written from scratch, with BVH acceleration and impulse rigid bodies. These optimizations help the game run efficiently, even in the browser.
What are some of the key technical innovations in this project?
One of the standout features is the use of a BindSAH BVH for the physics engine. This allows for fast raycasting and collision detection, which is crucial for a game like this. Another innovation is the use of a custom GPU-based particle system for effects like muzzle flashes and explosions, which are all generated in real time.
That's impressive, but how does the game handle AI and player interactions so seamlessly?
The AI is implemented using skinned soldiers with pathfinding, perception, and cover behavior. The player has a movement state machine that handles things like sliding, mantling, and leaning. The game also includes a weapons system with procedural reloads and ballistics calculations that take into account travel time and drop.
What about performance? How does the game handle complex scenes and effects without lag?
Performance is a big focus here. The game uses a number of optimizations, like per-frame WebGL program counts for hitch attribution. It also includes a profiling tool that helps identify performance bottlenecks. The developers even found that median frame time can be misleading, and they optimized the game to reduce stalls caused by shader compilation.
I see. What about the tooling and testing capabilities in this project?
The tooling is actually one of the most interesting aspects. There are tools for capturing screenshots, running shot sets, and even bit-identical reproducible captures. The Image diffmjs tool can compare pixel-by-pixel differences between screenshots, which is crucial for ensuring visual consistency.
That's really useful. Are there any limitations or caveats to this project?
Yes, there are a few limitations. For example, the project is still in development, and some features might not be fully implemented. Also, while the game is optimized for performance, it might not run as smoothly on lower-end hardware compared to native games.
So, who should actually care about this repo?
Engineers and developers who are interested in procedural generation, browser-based game development, and advanced 3JS techniques should definitely take a look. This project is a great example of what's possible with modern web technologies.
That's an amazing project. It really pushes the boundaries of what can be done in the browser. Thanks for explaining all of that.
You're welcome. It's a fascinating project that combines a lot of advanced techniques into a single, self-contained application.
I think this is a great example of the power of procedural generation and the capabilities of the web platform. Thanks again for the deep dive into this repo.
Exactly. It's a testament to what can be achieved when you combine creativity, optimization, and smart engineering.